थैंक यू। 14 આવશે રિઝલ્ટ સારું. રિઝલ્ટ સારું સમય સારો હશે. સારી વાત છે. રીડિંગમાં તકલીફ નથી.
हेलो हेलो हेलो
અત્યારે તૈયાર રાખજો. એલઈડી અહીંયા મૂકી દઉં.
અરે ત્યાં વાંચે ને એ લોકો આંખમાં આવે લાઈટ.
हेलो हेलो
પી લીધી જા મારા માટે ના લેવાય તારા.
हेलो हेलो माइक टेस्टिंग हेलो
શેમાં નાખ્યું? ટુમાં નાખ્યું તો વનમાં ઓડિયો કાઉન્ટ કરી દો.
ઓડિયો વનમાં
આપો આ બાજુ
વનમાં આપો.
વનમાં આખો બંધ કરી આ જીરો થઈ ગયો. હજુ આમાં જો ડિસ્પ્લે ખાલી થઈ ગયું શું?
હલો ચાલુ થઈ ગયું. હલો 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 હા બંધ થયું.
બંધ
હલો હલો સંપૂર્ણ બંધ બંધ થયું.
બંધ
બંધ બંધ સંપૂર્ણ બંધ થયું.
hello, hello, hello. Hello, hello, hello.
બેમાં ચાલો ચાલશે ને હજી મેઇન ગેસ્ટ આવ્યા નથી
નહીં આવ્યા ડિનર એટલે નાસ્તા
નાસ્તો ચા પાણી જશે
અમારે પછી બોલવાનું બંધ રાખજો.
શું કરે છે બોરે એક મિનિટ જોઈ લો Kucing ini dia loh kan. Ini begini. Yang pernah lagi dulu begini. आप जाओगे कुछ बोले भी ना सोशल मीडिया पे चलता रहता है एक्चुअली आदत आपको
Request all guests to take your seats, please. We are starting in 5 minutes. Request all guests outside the hall, please take your seats. Okay, so good evening all. I, Ritesh Shah, welcome you all to this unique, interesting and futuristic seminar on additive manufacturing, Pathway Toolkit for Design to Production, organized by Indian Plastics Institute, Ahmedabad chapter, sponsored by HP. We at IPI organize many seminars, including recently held national seminar as well, on various plastics related subjects like packaging, automotive, medical, pipes and fittings, various latest trends in various technologies as well. This is the first time that we come up with different and untouched subject, that is additive manufacturing. As far as I know, additive manufacturing or 3D printing allows for design and printing of more complex designs as compared to traditional manufacturing processes. It's a cost-effective technology for producing parts with complex geometries. Of course, we have a distinguished speakers here. They will highlight in the much detail on the subject. I request the audience at the last to raise your fingers for the questions so that you can get more and more benefited out of this seminar. Now I request all to switch off your mobiles or in the flight mode to maintain the continuity of the program. I now request Mr. Abhay Upadhyay, Chairman, Governing Council, IPI, and Mr. Prashant Trivedi, Chairman, Ahmedabad Chapter, IPI, to escort our Chief Guest, Shri Ravindra Gogleji, our distinguished speakers, Mr. Rajat Mehta, Mr. Franklin Dadhi, and Ms. Pooja Dave, to escort this dais. Now, as a ritual, I request all to stand up for the national anthem. Now, to honor the presence of our chief guest and speakers, I request Mr. Abhay Upadhyay to welcome Shri Ravindra Gogleji. Prashant Trivedi to welcome Mr. Rajat Mehta. I request Mr. Atul Kanula to welcome Ms. Pooja Dave. Then I request Mr. Mrunal Sangui to welcome Ms. Pooja Dave. I request Mr. Ankesh Parikh to welcome Mr. Natalie Lathi. Now I request Mr. Prashant Trivedi, Chairman Ahmedabad Chapter IPI, to offer welcome address to the gathering.
Good evening, everybody. Good evening. Good evening. That's the energy. Welcome all. Welcome to all the members of the dais. It's a privilege to welcome you all to this August function what we are organizing today. And this is the first time looking at the technology which is green in nature. We also thought that we will get it with a green substance, plants. So that's the initiative we have taken this time. The technology which talks about automation, modernization and innovation. IPI has got the same aim looking at these aspects. So welcome you all and look forward for a very interesting subject going down the program. And I hope you will enjoy the day. Thank you very much.
Thank you, Prashant Bhai. I now request Mr. Abhay Upadhyay, Chairman, Governing Council IPI, to update about the IPI and its activities.
Good evening, Ahmedabad. This is a very, very different subject than what we have been doing all these years. Let me briefly introduce you about IPI. Most of you know about IPI, but still I would like to introduce IPI for new people who have been sitting here. Friends on dais, my colleagues from plastic industry, IPI is a almost 38-year-old institute. It was earlier part of Plastic and Rubber Institute of London, then separated out in 85 and became Indian Plastic Institute. Today we have 14 main chapters and 2 sub-chapters across India. We also have 2 international chapters, Nepal and Sri Lanka. We do a lot of educational activity. IPI is basically an educational institute which imparts knowledge, it imparts newer technologies, it also does a lot of activities for students. So I request all of you who are not member of IPI, please come forward and join IPI because it's a noble institute and it's an institute with a cause. Secondly, it's not an owner's institute. I mean, it's not an owner's association where you need to be a factory owner or a business owner. You can be a professional. You can be a manager, you can be a supervisor. Everybody can be a member of IPI. So we look forward to all of you to heartily join IPI and make it a grand success. We already have almost 3,000 plus members across India. So you are most welcome to join. Let's all join hands and spread knowledge and positive side of plastic. Thank you.
Thank you, everybody. Now it's time to introduce today's chief guest, Shri Ravindra Gupta. Shri Ravindra Gupta is an electronics and electrical technologist. Due to his origins, being a great negotiator, he drove his career in the purchase industry as a veteran with more than 25 years of experience. He joined Tata Autocomp as the Senior General Manager Purchase in 2010. He handled purchase for Tata Autocomp Interior Plastics Division, Pan-India, spanning across diverse domains such as large projects for cost reduction, resource optimization, latest technological trends in the molding industry, lean and just-in-time, new competent supply development, engagement programs, along with leading training and building a strong team at IPD. In his new role, he is handling purchase for new plant and facility development across the entire Tata Autocomp and directly reporting to CEO and MD of Tata Autocomp. With this, may I request Duleji to come forward for his speech, to which we all are really waiting for, and request other dignitaries on dais to take their seat of the dais.
Very happy evening. Very happy evening, Ahmedabad. Keep sure. As we saw the starting only, Sahib, એવું કર્યું છે કે now we want to do something different. Sorry, if I delegate in Ahmedabad, everything is touch.
Touch me not plant. Touch me not plant.
I touch once in Patna, I don't touch. But તમે મને કોઈ સપોર્ટ કાઢી લીધું. Fine. So, coming back to Ahmedabad, I think last 15 days was a lot of happening in Ahmedabad. Navratri, Dandiya, World Cup. I think many of here would have enjoyed both. Dandiya and Navratri were definite, but World Cup also. Yeah. So point what Rajat bhai has made, the technology. So many years we are here to run our businesses in a different way. Nothing wrong in that. That was the need of that hour. But today, can we run the same business in the same old way? Is a really a big question. And when especially the only permanent thing on the earth, that is the change is happening every moment. I will not say that every second, but every moment. Something or other thing is changing and pushing us to adopt that change, be a part of that change, and continue to business sustainable or whatever way. Otherwise, things are going to be very difficult. So just if we embrace the change, then only we are going to succeed. And this is what I just wanted to show the Ahmedabad, what we enjoyed the last maybe 2 weeks back. But really if we see what is happening on this, cricket is a pretty old game. Maybe 100 plus years, British started and all that history is okay. But when they started, it was a big match of 6 days and all that. Then they came 1971 ODI, one day, it came 50-50, T20. Very fast transition, all this happened. And now what is going to happen in 2030? At least I don't know, but if anyone of you knows, please share with me. What do we expect after 2020? 10-10. That's over. A lot of visionaries we have here. So just see the change. But what I see in this, what remained constant, 2 batsmen, bowler, number of stumps, bells, size of the ground, everything remained constant. 11 players on both sides. In some countries there are 13. Our country we have 11. And playing rules have become more and more stringent. But why this entire transition happened from 6-day match to just T20, and that too playing in the evening when we can watch? What happens with the player is a separate thing. Right? Yeah, you can please speak loudly so that everyone to know. Definitely. Earlier we had a commentary because we used to had only radios. But now we have a TV where we can see, so definitely content of the commentary has gone down, but still, if you give me the choice, I switch on the TV and the commentary on the radio. Okay, that makes that live. So I make a combination of both. So definitely, yes, commentary has also changed. The speed, making it more live, because person who cannot see on the TV, but that commentator skill makes it live. He can enjoy that as if he is in the stadium. So if these are changed in the sports, I don't know what has happened in the industry. Moreover, same. If I talk about our own company, Tata Motor, we started way back in 1945 with the first car. And today, if we see the first few years, cars were launched after a few years, 10 years, 12 years, like that. But if you see the speed in last 3 or 4 years, cars are getting launched practically every 3 months, 6 months down the line. Basic car which was invented maybe 100, 200 years back, same is today. 4 wheels, steering, some sort of a prime mover, something is a gearbox or transmission, whatever we call, nothing has changed. Again, this transition has happened. Why it has happened and what we expect in 2030 now? Maybe autonomous car, maybe different technologies, I don't know really. So what is happening in sports, what is happening in car industry? Car industry, just we are taking other example. Practically it is happening in each and every industry. Let it be communication industry, let it be textile, let it be food industry, stock goods, white goods, anything we say. Nothing has changed. And what we are today. Before getting into this slide, I may be making a small bold statement here. Everyone sitting in this hall is he a customer or a supplier? Either or. Okay. Both. Okay. Anybody would say none? Either I am a supplier, not a customer. Sorry? Consumer. Okay. But if you see the consumer or a user or whatever, which role he is in? Is he in the role of customer buying something or is he in the role of selling something? Either providing the service or availing the service. Both. So within me, one part is the supplier, another part is the customer, and I keep changing the role. For my end customer, I may be the supplier, but to my supplier, I may be the customer. Does it make some point? And today, if I talk personally, I am losing my patience as a customer. I need everything right now. Everything I need best on the earth. But the price, what I tell you. But अभी तो दिवाली का जमाना है, buy one get two. So that is also customer driven. So if everything is that requires instant gratification, that's why all these Zomato and Amazon has come in. I'm sure hardly I will see anyone here who is not aware of Amazon, who has not ordered anything on the Amazon. Is anyone who's unaware of Amazon? No? So everyone knows. What I like the most in Amazon, the moment I place an order, immediately on my sale I get a notification. Order is placed. Material is in stock. Material out for the delivery. Material on the way. Commentary again. Material is delivered. Received by so person. Till date, I am sure neither I have called, none of you must have called Amazon for any follow-up calls of the material, delivery or whatever it is. That's what customer is expecting. Supplier's job. The moment I place the order, till I get the material at my doorstep, and till he has to tell me it has been handed over to the supplier in a good sound condition. And still, next services, if you don't like, return it back. We keep it aside a little bit. But this is all happening because the customer pressure is there. And none other than all of us sitting here are the customers. We are putting this pressure. Because the moment I want to do the follow-up with Amazon, मेरे material का क्या हुआ? I don't think next time I place an order with him. Same thing is happening with Zomato. If I don't, he doesn't deliver my food within time. Many times, many people pray that he delays so that I get free. But what time they allow? And in Pune, I have seen the order with the Zomato guy, coffee from one shop, pizza from another shop, some dessert from another shop. So our dinner is delivered at my end, maybe by different delivery boys. So sitting at home, I am enjoying the entire different type of cuisine, different type of food, different taste, everything whenever I want. And practically throughout day or night, 24/7. They don't have any holiday, they don't have rain, cold, nothing. He's again a customer, he is impatient, nothing else. At the same time, he wants to be perceived as a tech savvy. All of us, we as a customer, are we not demanding innovation? If I see my first car 20 years back and if I see my latest car, definitely we only pushed our suppliers, our car makers, I need this feature, I need that feature. Just check your mobile phones. If some of you must have used the old Nokia, which used to weigh almost 500 grams. And today's mobile, what features that mobile had and what features today's mobile is having. Does it happen that industry made it or we demanded it? I don't want to carry camera and the notebook, Casio notebook and camera and the cell, put everything together. Put notepad, put alarm clock, and n number of apps, n number of. Customer is demanding, customer is innovative. He just gives us the demand. How to do it is your problem. If we can think, we can make it. This is how today's industry is running. If you can think and if I can't make, then I am out. Somebody else will replace me. I cannot think what I can put in my mobile or in my car or in my product. If you can think, just tell me. And this transition is going to be unprecedented. It is going to run at a very, very high speed, whether we like or we don't like. It is going to run. If we talk about our latest current government and the Vande Bharat train or all such trains or metro trains, why they have come to the India? Just if we see 30, 40 years back, what are the trains journey? What is today's train journey? Now we are getting a bullet train from Ahmedabad. It's no more dream now. If we don't adopt this, as a nation will be far behind than others. We have to adopt these latest technologies. It will be impossible to the today's business, whatever smallest business I am doing, let it be a chai ka thela, so like a biggest industry. If I don't use digitization, tea stall guy delivering a tea to the Zomato guy is nothing but a digitization. He gets the order on his mobile. He may not have a laptop or a very high-end server. The server he is carrying in his pocket. Correctly, if I am saying wrong. He knows the digitization. You go to any vegetable guy, he got a GPay. Just 10 rupees payment is being made by the GPay. It has gone to that grassroots level. And industry still, if we don't adopt this latest technology of digitization, and now getting replaced by the ChatGPT, interactive AI. You ask the question and it answers the way you want. I make a mail, I give it to the chat guy, he corrects the mail and gives me the solution. I need not to bother about my mistakes, my grammar, my statement making skill, nothing. Time is changing so fast. When did a ChatGPT launch? Just a year back. Before that, Facebook, Instagram, everybody took 5 years, 10 years, WhatsApp 10 years, but ChatGPT replaced everybody. Just 1 year old. What a transition. First technology 10 years, then 5 years, now it is 1 year. Everywhere speed is going up and up. So I feel either we enjoy the breakfast or we become breakfast for somebody. If I don't enjoy the breakfast healthily, somebody is going to enjoy me. I will eat breakfast. And another thing, what everyone is talking today, since I am in the purchase, so a lot of our supplier partners do always complain there is a huge competition. Thanks God today I know who's my competitor. But time is coming now where we don't know our competitors. And which part of the world he is. Whether he is in India or whether he is in US or whether he is in Europe, we don't know. Just imagine, we knew very few car companies making cars, but now if Tesla and Google and both people started making cars, has anybody thought of it a few years back? The software companies will get into the automobile industry. Just simple that Hyundai must have thought the competition of Suzuki, Suzuki must have thought of Ford, Ford must have thought of General Motor, like that. All known competitors. From where these unknown competitors popped up? And not only popped up, he made everybody's life miserable. Really, we don't know who's going to be my next competitor tomorrow. And how many? From which field? What he is going to do with me? So all this is making really a challenging time for all of us. But how to deal with this? Everybody talks of the VUCA world, there is a lot of volatility, a lot of uncertainty. It is going to be there. We can't avoid. What is happening outside of this room, we don't have any control. But I have a control what is to be done in this room, at this moment. So that VUCA volatility is going to be there. It is a part of our life. This turbulence in life is going to be there. Even if you ask the school-going children, they also have a stress. CEO of the factory has a stress. How to deal with this? How to deal with this turbulence? If I use my old tools, I don't think I'll be in a position to meet that challenge. I have to change to my new tools. That's what that Peter Drucker sir has said. The greatest threat in times of turbulence is not the turbulence at all. Let's not complain about turbulence. But to act with yesterday's tools is an entire wrong attitude, wrong way of handling the turbulence. Now, hardly anybody must be getting in a traffic jam situation. We know the Google map tells us, this side is the red, this side is the orange. Please take a longer route of 5 kilometers, but you can reach in time. Handling the same traffic jam with a new tool. Simple Google. Such tools, everyone has to use it now, otherwise it is going to be difficult. What happened with Nokia, Kodak, everybody knows. They have not adopted the new technology in time. Today, no one there. Means once upon there was a giant in their life.
What is ERA?
Era.
Era. Okay.
Today's era. Because today, me as a customer, I am totally impatient. So this entire today what is happening. So this generative AI is going to make a lot of changes in our day-to-day life. So in simple example, what I wanted to show here is a seat belt bracket on the back side of the seat where the both sides, left side PLC and right, they have to put the belts. So this bracket was designed having so many parts. But simply AI was given this challenge. AI found out this solution, I can combine this. 8 parts are replaced with one simple part. And where the 3D and AI has helped us. But if I would have not taken the help of this technology, I would have made to use steel old press parts, make 10, 12 different parts, assemble them, join them, make the gauges and everything, and continue. While my competitor will make a very simple part, which is a cost effective, he can produce in a absolute zero error and everything, being a safety item, seat belt and all that. So really it is going to be a disruption today. Entire technology, entire thought patterns are getting into that way. And this technology, AI, is now at our fingertip. It is available in our laptop, it is available in our cell phones, everywhere. So it's not that we need to find out. Coming back to Ahmedabad, our famous saint, Bapuji has said this Mahaji, which many of us, we agree on the photo, but heart to heart we don't agree. Customer is the most important visitor in our premises. But many times I find a lot of complaints against customer only. The customer is pushing, customer is demanding, customer ye kar raha hai, customer wo kar raha hai. He is not dependent on us, but we depend on him. Yes, I say it, but at the end of the day I don't deliver in time. Sorry, you may sound little bit I am talking negative, but from the purchase side I am just trying to put those points. And I am sure when you as a customer are in picture, what you say, talk to yourself and to other your suppliers is not different than what I am trying to tell you. He is not an outsider in our business, but he is a part of it, but we don't include him in our family. Same thing what Steve Jobs is saying now. Get closer than ever to your customer. We get closer to our customer for the dinner parties and those. Steve Jobs sir is not meant, definitely meaning that. So close that you tell them what they need tomorrow. What my customer is doing today, if I know well what are his plans for the next few years, I can understand what technological changes he must be going, what technological changes, production changes, my approach change I need to do today so that I am future ready for my customer tomorrow. So before he asks, I am ready. Before customer demands anything, I am ready. Hardly customer will get a chance to find my replacement. Our Hindu marriage, LIC policy, जिंदगी के साथ भी जिंदगी के बाद भी कस्टमर मेरा आज भी है कल भी मेरा ही रहेगा. That confidence I should have. Customer cannot think of alternative because what he wants he doesn't know, but I know, and I am ready with the solutions. What services he will need tomorrow I know today. I can give him. See, that is how the Amazon and Zomato must have come up. If I don't deliver it in time, you penalize me. Enjoy free meal. Customer never asked him, what is the penalty? They themselves have declared, if we don't perform, this is the penalty on us. We never asked that you update my order status. They did it themselves. Similarly, if I read my customer mind, his aspirations, his development plans, and if I get ready for myself for the future ready in true sense, I am sure this is going to happen with me also. This is very common statement, but very bold, but very few are ready to operate it. Definitely in Ahmedabad, I am sure you people are doing it. The cave you fear to enter, where I know कि वहाँ पे मेरा treasure है वो cave के अंदर, but still I fear to enter. Just I have to come out of my comfort zone, nothing else. Get inside the cave. There is a lot of gold and Kohinoor diamond and everything kept there. I know it, but I have a fear to enter. Fear to dare to try something new technology, new innovations, new ways of working. Many times in the industry, my personal experience, first time right or quality, PPM is all talked and acted on the shop floor. Shop floor is just one part of the industry. What about my finance, purchase, marketing, security, administration, HR? They don't need first time right. They don't need lean processes. They don't need SOPs. They don't have KRS. They don't have PPM. If a financial person making a 10 finance entries and out of that 2 are wrong, what is this PPM? What is the hit to the company? What is the loss to the company? What is the production I talked? One part fail over. But what is the HR? One apartment letter is not shared in time. One security person makes the wrong entry. Security person allowing one wrong entry. Person. So really, these are required at all levels. Just check the sound. Self-explanatory film, no dialogue, nothing. Embracing the change. Dinosaur was the biggest, strongest. Where is today? The smartest animal, where is today? Today is the era of survival of fittest. That's it. I may not be strong, I may not be smart, but I can get those people in my team. I can get scientists in my team. I can get PhD engineers in my team. I may not be smart, I may not be strong, but I can make my organization fit. So evolution is absolutely irreversible. We can't go back in time. It's a question of only survival, nothing else, whether business survival or anything, fittest is going to survive. And business fitness today depends on customer-centric approach, nothing else. We as an owner or the top leader or management, we have to spend 80-90% of our time to engage with the customer, not doing day-to-day jobs in our organization. If we keep doing it, we lose the focus on customer. And finally, he is the main purpose of our business. I sit with customer, I see his plans, I know his technology, I know what are the plans, and then accordingly I change the direction at my end. What he wants, what he may need tomorrow, day after tomorrow, better I prepare. Embracing latest technologies. Let it be any technology. One of the technology what we are today talking is 3D printing, additive printing. Okay, fine. There are the latest CNC machines available. If you go into machining, molding machines are available. Everywhere there is the latest technology. Use of AI. Let's make the use of ChatGPT. It is not just for the entertainment. Really, we get a lot of good information out of that. Skill enhancement is absolute neglected area in our country today. I'm sure everyone will agree with me today to get even a single skilled manpower, how easy it is. We can buy machines, as many as we want, latest technology, latest softwares. Can I get a manpower? What is the difference between us and a European or China or Taiwan? Everybody is using same machinery, same raw materials, same softwares. Just a man behind the machine is making difference. This is my personal reading. I may be wrong. It's not that we are using old lathe machines or the hand molding machines. Shri Sunny is here, he can vouch for me. What machines are available today in India, the same machines are being used in the China, Taiwan or Europe. And if not, I can get the European machines here. I can get the European raw material here. Everything is available. Unfortunately, I don't get the working manpower from Europe and China. But they are not that far. If it starts happening, so really we are talking on one side China plus. But I say it's not China plus, no, it's the India plus. Why we have to compare ourselves with China? Many of the people, whenever we visit, their first question, what about the business? क्या business का scenario आ गया? Simply think, on this my small desk, how many items are India made? On this small desk. Half of it is out of India. I'm sure this microphone is out of India. This is out of India. Either technically or cost-wise. Why we can't afford when somebody else can afford? So what is the question of business opportunity? Business is like just in front of me. It's ready on the platter. Can I take it? Can I make it? To ban China is very easy. But what option I am giving to the customer? And if I get this product in India, let's say at 10 rupees, I import at 10 rupees, still people will love to buy. But if I can make it 10 rupees, if available at 2 rupees, and much better quality, who will buy my product? So just ban one country or ban one product is easy. So really skill enhancement at all levels. I am again coming back to the same point, it is just not on the shop floor. It is at every level. A communication call made by a call center person or a order booking guy, he has to be absolutely precise in one shot, things are done. No recall. It's a wastage of time from my side, other party side. Adaptability to change. Really we are not adopting that fast technologies, fast changes. And future ready organization. Then only it can happen. Otherwise really we are going to miss the bus. Thank you friends. This was just a takeaway from what we see in the industry.
Thank you, sir, for your very inspirational speech and what is the requirement of the future and how we have to grow up accordingly. Now I request Mr. Atul Kanuga, past President, Governing Council IPI, and our mentor as well. Also is an environmental committee member, Blast India, to offer a memento to Shri Vijayaji. Now it's time to start our technical presentation. would like to introduce Mr. Rajat Mehta first. He is a visionary leader and strategic advisor with more than 30 years of professional experience, including 2 decades in the same organization. He possesses strengths in strategic thinking and execution, with proven success in spearheading technology business and lead digital transformation. He is a technocrat with proven adaptive skills to handling technologies with extensive knowledge and experience in cloud data center, GPU computing and edge devices. He has successfully launched 6 new technology businesses for HP India. And about Ms. Pooja Dave, she has BCom and LLB honors in corporate and business law from Nirma University. She is a founder of EB by Loyalty and Gifting Ideas. She is also Vice President, Strategy, Expansion and Digital Manufacturing at Innova Systems, India. And with this, I hand over the desk to Mr. Rajatji.
Sorry for that. Technology sometimes is a problem. Good evening, everyone. Good evening. And thank you for coming. I have met everybody probably on this side. I have not met this row. So if I bore you too much, you can throw whatever or just raise your hand that we are getting bored. But don't beat me on this. Before we start, let me set the context as to what we are trying to do. Okay? And most of these seminars, what happens is that people come and try to sell a technology. So let me be very clear, I'm not here to sell you a printer. That is least of our intention to sell you a printer. And you don't have to buy the printer for next year or so. Let me be very clear. So this is not a sales pitch, but we as HP see their value in this technology. And we did a couple of steps to make sure that entire India benefits from our technology. And today we will be talking about how as an industry you can use this technology and other technologies in this domain without investing in printer in-house. Once you get ready with the technology, if you decide that okay, I need it, then obviously we are there to sell it to you or lease it to you, but not right now. Okay? With that, I wanted to set the context before I start. Now, introduction can be very, very elaborate, but I am a mechanical engineer, started my career with Jayagar Maruti. That was, a lot of you were not born. 1993 is when I started my career. And I started my career with R&D and quality control. So I'm hands-on. I used to climb on Kojima presses and make sure that the stamping is done properly. I have tested cars on test rigs. I have done indigenization of vehicles. So if you had old 800 which was like this, to this was done by me, including the exhaust system. And then one fine day, one salesman came and he said, "You are at the wrong place." And I asked, and that time because I had just graduated from a private engineering college, only criteria was money. And my question was, if I am at the wrong place, what will you give me? And he said, "We'll double your salary." And that was my criteria of moving from a manufacturing industry into a computer industry. And I started doing CAD/CAM CA. And from there, I've been with HP for 24 years. There are a couple of logos here, and before I get into, you see Innova, you see Premium, and you see Reddington. Let me introduce my partners. We at HP are firm believers that we need partnerships. We need partnership with you, we need partnership with our software vendors, we need partners with local players. What you see as Innova, they have been our partner for Apurva around 24 years. 24 years. So I have known Apurva for 24 years, and when I looked at Gujarat, my logical choice was not Apurva, but it was a girl standing here. Let me introduce because I'm taking your limelight, but she's 23 years old and she's supporting 450 women and running an enterprise which is promoting Gujarat handicrafts. And when I looked at Apurva, I said, "No, Apurva, you cannot run my business. I need her to run my business." We need people, young blood like her, to actually take the country forward.
Good evening, everyone. As my age has already been mentioned, so I don't have a really long career gap. But with the academic qualifications that were said, you all must be wondering why I am into 3D. So as Rajuji rightly said that my father has been associated with HP since last 24 years. So when my father started Innova Systems, it was printer plus services. So he started with the paper printers that we get today, the Xerox machines and the copier shops. So when I entered his business, along with his guidance, I decided that he started with 2D, so I should be doing 3D. So 6 months back, if anyone would have asked me about 3D printing, I just know that there is a nozzle like this, which is when heated, would bring molten plastic, and whatever we have programmed, that product would be generated. So in March, my perspective regarding 3D changed. I realized that it is more like a sand castle that we build on the beach. So there is. Do I need to talk more about technology?
Yeah, please go ahead, please go.
I'm completing whatever I know because that is all that I know. There is a huge box which has sand, which has like powder, and there are two agents. One is the fusing agent and one is the binding agent. So whatever product that you imagine and you foresee can be built. So earlier, 3D printing, even I thought that it is more like a prototyping job. It can only cater to prototyping projects. But as in how we look into industrial 3D printers, we realize that it is prototyping plus low volume production, and certain parts which conventional manufacturing processes cannot do, 3D printing can very accurately do it for you. So I would be using very simple examples. We have Tupperware boxes, like we have 3 boxes, one big, one smaller than that. So all plastic people, if we have to make it, we would need 6 different molds, right? And 6 different machines as well to make that. But using 3D printing, you can print one part, inside there is another part, and inside there is one more part. So why, when I got this example, I was so sure that we need to get this technology to Gujarat, is because 6 machine નથી લેવાના, 6 મોલ્ડ નથી બનાવવાના, એક જ sand bit હશે, એમાં 600 plus or 6000 plus or 6 lakh plus products can be made. And assembly line નથી બનાવવાની because assembly can be done inside the machine. The way you design the product, that is how it can be made. I think he has prepared a 42 slide PPT, so I should.
How many marks? What marks should I give out of 10? 10? I think I'll give her 11. On a personal level, I've been mentoring her for almost 2.5 years. She's one of my brightest mentees, and I'm really proud. And that's the reason when you asked me why I want Pooja to be here, that was the reason, because as a mentor, you really love to see your mentees do well. And I am convinced that she will do much better than I did in my life. So thank you, Pooja. You can
You just told them the reason why I deserve to sit over here.
Yeah. Okay. We have a tradition of breaking a coconut. We always do. And I don't have a coconut. So let me tell you why we feel this technology is very new. In my hand is a part printed in PA12, polyamide 12, and I am holding it. Okay? Any drone which you see from Idea Forge actually uses our technology. Okay? And this is the reason why they use it, because it's extremely flexible in terms of what we can do with this. So this is one example. Same material, okay? PA12. So strength. Same material, but with a built-in mechanism printed in one piece. And you can see this routine. I will just pass it on. Okay? So this is the power of additive manufacturing. Okay? Let's go a little faster now because we have. Let me take a roll call. How many are automotive ancillaries here? People who supply automotive components? Just raise your hand. We'll give some exercise. Only 2. Okay. How many are industrial? Quite a few. Robotics and industrial automation? 1. Doctors? Wow. Anybody in orthotics and prosthetics? Okay. Educationists? Okay. Most important people. As we heard Chief Guest talk about it, skill is something which is we are struggling. Believe me, I have to hire 2 people in India and I'm not able to get it for last 1 month. 2 person who can be a little butcher and manage our channel. So it's very, very difficult to get, and we will work with collaborative schools and colleges in Gujarat and see how it can make a solution forward. As I promised, there will be no marketing side except for this one. Just wanted to share what HP is bringing to the table. We are a $63 billion company globally. We are a Fortune 59. We have 28,000 plus patents, 250K partners, 58,000 employees, and we operate out of 180 countries. When a company like HP bets its future on 3D, means that we see the future in 3D. Otherwise, we will not enter it. And it's a very small part of the business. It's probably 0.1% of our overall business still currently. But we have invested over $1 billion in this business. 1 billion will be all the 3D printing companies together. Turnover will be less than $1 billion. And we have invested that in the R&D. Our R&D in Barcelona is of the football size, basically football stadium. Additive manufacturing is not a replacement technology. If anybody comes and says that you don't have to do injection molding, and if you're wearing a 9 lathe machines are a classic example, that you take a stock and you start cutting. So that's subtractive. Formative is that it basically takes the shape of the mold. It could be a sheet metal or it could be a molded plastic. So injection molding is formative technology. Sheet metal forming is again another example. What happens when you, how many of you are designers? I will make it very interactive, otherwise it becomes boring. Okay. When you get a new part, how do you design?
Take dimensions of that.
Okay.
Conceptual. What is the requirement of the client?
Okay, so if I have this part, how will you design? Okay, this is a solid model now. You have to manufacture. What will be a constraint when you decide what to do? How will you constrain this in terms of manufacturing?
Material.
Okay.
First.
The first constraint you will have is the type of machines you have in the shop.
And the material.
Whether you have a 3-axis milling machine or a 5-axis milling machine or a 7.5-axis machine where you can swivel the base. Okay, that is one. The second important thing is parting line. You need to eject this from the mold bed. and then finally you have to, so basically you start conventional manufacturing designed by constraints you have. The 3D printer only does remove, what it removes is the constraint. Okay? How many of you understand 3D printing? Raise your hand. Let it be very interactive. Okay. How many of you have taken 2D prints on a printer, HP printer, everybody, right? If you stack each of these prints on top of each other and stick it, it's 3D printing. Simple example, if I take an apple, cut it horizontally into slices and give back the slices to you and say assemble the apple back, what you will do? You will stack the layers again. So this is additive manufacturing. You are adding material instead of subtracting material. Okay? Now this is where it starts getting interesting. You thought it was very simple, right? You can just hold and stick apples. But these are the technology which are already available in 3D printing. The problem in industry happens is that a sales guy comes in and probably will come, can I see the pointer? Okay. He might come with something called fused deposition modeling, FDM, one of the oldest technology. Okay? And he'll say, sir, I have got the world best printer. We are 30 years in the system, in the country. We have 450 printers. I'm not naming the company, but what you will do, most of the engineers will take out the conventionally designed part and give it to them. Isko bana ke leke aao. He will go, create that part, and he will oversell the printer and he will buy the printer. 99% of the organizations who are using old technologies are not utilizing the printer, because this can only create prototype. Now to give you an example, let's take a food example. How many of you are chefs here? I can see one, we spoke. How many of you can cook? Okay. Which was the cake which was given to you for your birthday? Pineapple or chocolate? Chocolate. Okay. How many of you got the pineapple cake? What is the toughest part in a pineapple cake? When you cut it, what happens? You can cut it like this, but the layers break, and you can see each layer because it spreads, right? But if you have a chocolate cake, it sticks around. What does it mean scientifically or engineering?
Binding.
Exactly. So, if you are doing production 3D printing, you need to be isotropic in nature. X, Y, and Z have to be equal strength. Otherwise, you cannot put it in a running engine. It will disintegrate. You cannot put it on the satellite. Okay? So, these were the choices which we had when we started. We came in 2016. Most of the companies were 30 years old. I launched the printer in India in 2019. So we were good 25 years away. And today we are the largest used printer in the country. Because the technology we chose was on 3 deliverables. Speed. You want it to be fast. Second was material. It has to be engineering grade material, which can go into the moving part. Third was the isotropy. That it should be equal strength, X, Y, Z, better than injection molded. Otherwise, why would you use it, right? You cannot if you... And 90% of the organization did a mistake here of buying technologies which were not giving isotropy. So R&D, very nice, you can print a prototype, but the moment you want to do a functional prototype, make a zig out of it, it will break, and it is of no use. Okay? These are the 2 technologies. I will not go into too many details. Whenever you are using 3D printing, there are certain advantages. I will increase the speed as we go. One is the design freedom. The second is lightweighting and material. Rasha, can you give me a lightweighting example? Shorter lead time, increased flexibility, on-demand manufacturing, customization and personalization, tool consolidation. Okay? Lot of words here. I'll give you a practical example. COVID. Okay. Biggest nightmare for everybody, including Government of India. No ventilators, and the first wave, second wave were really deadly. You won't believe we manufactured 30,000 ventilators using our technology. to the ministry. HP is big. We do $2 billion in India. So we went to the ministry and we said, please allow our trucks to move. We need to shift material. And just in Chennai, we did 1,20,000 trucks. And we did it all across the country. If you have heard Prime Minister Modi, after that, in the parliament, Lok Sabha, he said 3D printing is the way to go. And that basically capitalized the whole 3D printing world. I'm very honored to have people from ISRO who are sitting here. Latest mission to Chandrayaan and the sun. What do you call that, sir? I missed the name. Yeah. Aditya L1. Great example of how 3D printing is used in their technology. Not mine, not HP, but they use different technologies, but they use 3D printing. And this is where innovation can happen. Sir mentioned about India plus one, India plus two. Look at the drone industry. It has taken the entire world by storm. India has 35 drone startups. One of them has IPO already very successful. Idea Forge. We have Garuda. I got 2 success stories today from another 10-member team who created an autonomous drone out of IIT Delhi. If somebody wants a story, I have it on my phone. We created global story. This is what can a technology like 3D printing can happen. What we need to do is apply the mind where we want to use the technology. And because we are adding material and not subtracting material, it's sustainable. It's green. You're not wasting material. Because we are not using any kind of welding, we are using infrared light, hence the power consumption is very, very low. And look at the possibility that today if an aircraft is not working in Ahmedabad, Airbus going, and I'm giving you a hypothetical example to make it a little dramatic like Shah Rukh Khan movies, that the plane is broken down, the part does not need to fly down. Using blockchain, a digital file will come in and the printing, next closest printer probably, Pooja will have a printer in her office and she can print and give the part that, okay, there's your part, fix it in the plane and ready to go. This has already started happening in the shoe industry. How many of you wear shoe 8, size 8? A lot of you, right? Women are setting 6 and 5 and 6 is a popular one. We go into a shoe shop and we all buy the shoe size 8. All shoes are same with all the kind of defect. And then when we walk like this. Because a person heavyweight like me needs extra cushioning, or I might be a flat-footed guy. Now, I don't have to go to a hospital to get an insole printed. I can actually put my foot in the showroom, and it's happening in US. I can put my foot down, take the measurement, pressure measurement, so people who are a designer, it's a CA map, right? I take the CA stress map, and I know exactly where the stress is, and I design these insoles. And this insole goes into my shoe, and it becomes a customized 8 size shoe for my feet. It can also happen in the cranial helmet, which you see here. Children with defect, skull defect, they need helmet, but they can't wear a heavy helmet. So we make it hollow like this, so that there is a lot of air passing through, and we make helmets for children. And in one shift, we can make 15, 20, Basha, how many helmets can you make? Around 20? 20 to 22 helmets in 10 hours time we can make and give it. And each helmet will be personalized, will have patient's name, will have a barcode, so that there is a traceability, and that's the power of additive manufacturing. Okay? My request to you, and especially to designers, when you go back tomorrow, think of this curve. This is a classic design curve or a production curve. You start with prototyping, you reach a peak where you start doing manufacturing, and then there's an end of life, and then there is a spare part requirement. If you really have to use additive manufacturing, it should apply across all the range. I met Pravindra sir almost 2 months back, and believe me, that day also we didn't do a sales pitch. Today I had a coffee with him, I didn't do a sales pitch. Because until I figure out that how I'm going to solve this problem for TACO, I'm not doing any justice of being a salesman, of selling a technology. So as an engineer, when you're looking at a technology, look at this graph. And always remember, can I take this problem out of this equation? What will happen? If you don't require tools to create spare parts, what does it mean? Anybody? You're freeing a lot of cash flow for your company. Otherwise, the dies and tools will be dead inventory lying there. Somebody someday would require one piece because his car or a vehicle or a scooter failed. You will put the die back onto a press or onto a milling machine and print that part. Instead, if you have a 3D printer, just fire the print and give the part. HP is the largest supply chain. We manufacture one printer, one PC every second. And let me give you 3 examples from our supply chain where we are using 3D printing. And now I will increase the speed. The first example is a locating or a guide block. Typically, in olden times, Majboot car matlab ambassador. Today the Majboot car is Tata because steel hai Tata. That's what we say, no? Safari le lo, road pe chalo, kuch nahi hoga. But what happens as an engineer, we have been over-designing a lot. And this block, our engineers designed using CNC machine. And the function of this block is only guiding. It's a guide block. So when this came to our research center in Singapore, we said, do we require this block to be in metal? Why don't we try and do a stress analysis, FEA analysis, finite element analysis. And we realized that we can do it with plastic. So we converted from aluminum 355 gram to 80 gram block. Then I said, can we make it hollow? Yes. Okay, and it's quite strong. And we were able to bring it down to 55 grams. And then there is something called generative design. How many have seen a tree grow? All of you? Are you able to design an equation how a branch comes out of a tree? Anybody? Any education professor who can tell? No, right? This is nature's magic. Some of that magic has been captured by software like Materialize Magic, Anthropology and others to do generative design. And we use generative design here and brought it down to 23 grams. From 355 grams aluminum CNC machine to 23 grams. And now we keep it in the jar. If a part fails, we just ship one part to the, and this, every plotter you use in your organization has this part. So imagine the amount of cost saving. 93% weight reduction, 95% carbon footprint reduction, and cost reduction of 50%. This is the power of designer when they think disruptive. Why should I follow the convention? Can I change? Let's look at one more example. This is a drill extraction chute. Okay? Machining, all CNC machine, 575 grams, $450 cost, 13 parts, or MOQ means minimum to order quantity. If I have to get this block again, I have to order 13 blocks. And that is 3 to 5 days. You know what this block does? How many of you use HP printers, laser printers at home? The print head has holes. This small part actually just extracts the slurry out of the drilling machine. There is no other function. Our engineers converted this into plastic and created a jar of this. And next time what happens is this, on this portion, which you can see here, the slurry used to get stuck. And we have to dismantle it, clean it, entire production line goes to hard. Today we have a box of this and we just replaced. What we have been able to do is, we have been able to reduce it to 52 grams, $18, just one piece is required because it's all combined now, and 1 to 2. Again, 95% cost reduction and 90% weight reduction. Last example. You can look at this as a HVAC. Okay. Typically, the mistake most of the engineers are doing is trying to create a conventional design HVAC and trying to 3D print it. This is the right approach. Look at the whole assembly, consolidate the assembly, and then use generative design to reduce the weight. Again, substantial amount of cost saving. And if you go with this logic to your management and say that I'll be able to reduce weight on 100 components by almost 50% and save cost, you don't have to justify the printer. The printer will automatically come. Okay, let's look at some automotive examples. In front of you, I don't want to talk about being an automotive expert, but I started my career and I'm still very passionate about it. I drive a Tata Safari and I'm very proud of it. It's a Kaziranga edition. It is one of the most complex supply chain. There is Minda, there is Motherson Sumi, there is Sunfab, there are so many others who supply components. Okay? It's very complex. One breakage, the line stops. One supplier is not able to give, you need to have alternate. Molds are really expensive and have long lead time. Aftermarket supplies eat the cash flow. Prototyping is expensive, design iteration are expensive. Like earlier we had one model of Ambassador, the second model Mark II used to have just instead of metal front, will have a rubber front on the bumper. And that became Mark II. Today Tata Safari, I bought it last year, okay? And I'm so upset that they launched with ADAS, the new one, has a new steering column which is electric in nature. I have to do an exercise and I'm fat, it's very difficult. So it is much easier to drive now. It looks much more classier. The sister concern is JLR is actually defining the design language, and now I feel jealous. But look at from an engineer's standpoint. He's got 6 months to 8 months to churn out a new model. And it has to be a significant upgrade. You cannot do it from a mold and create it. I'll give you one practical example. Anybody from Mahindra here? Nobody tells Mahindra that I gave you this example, okay? This is between friends. XUV 700. First 400 vehicles. This guy standing here actually created almost all the door handles on 3D printer and gave it to them. The first 400 vehicles were running with 3D printed handle because those were marketing samples. Another example from Tata Motors. Auto Expo, right? Everybody wants to enjoy Auto Expo for various reasons. I go for food. Some people go for looking at new cars. And because we have very few diversity here, I will not talk about the other reasons. Okay, but the fun part is that a company like Tata Motors needs to print at least 2,000 parts for Auto Expo alone for getting that pavilion ready. And when Tata Motors bought this printer, I was talking to Mr. Vaidya, very respected man, very, very knowledgeable on native, and he said, the reason I love this printer is because of for Auto Expo, all the 1,400 parts were printed. That's the power of engineer, when he knows when to use a conventional manufacturing and when to use additive manufacturing. Okay? Now we will start running. So for automotive, it gives you design freedom, cost reduction, and time to market. These slides will be available on request, so send me a mail and I'll send this slide to you. Let's look at some examples here. Packing and sorting, transport. I'll give you one example here. Ford Motor Company India, before they decided to quit India, which was unfortunate because they have some good vehicles. We went down to the shop floor for something called discovery, where we walk with the engineers on the shop floor and identify components, which components can be 3D printed. And we saw that they were using metal cradles to transport the engine. And we gave our engineers a challenge, can you replace this metal with a plastic? Okay. And I think the person's name was Sridhar. He said, not possible. You cannot do this because engines are heavy. And you won't believe in 15 days time we replaced it with a plastic component which I threw on something similar on PA12 and we were able to do it. Now from a company standpoint, look at what we have saved. All the bins which they have, where they use transport engine, they had aluminum machine blocks to keep the engine safe and away from damage and transport from one plant to other. All that can be replaced with plastic. Okay? This is one example. What you see here is a robotic arm. How many of you use robots in your shop floor? You do. Okay? Now we have the capability of printing the end of arm tooling using the printer, which is plastic in nature. And actuate the part, because we are airtight and watertight, you can use air and water to actuate the arms and pick up stuff. The advantage is that on these servo motors, you lighten the weight for the servo motors. So this is another example. Now, if somebody tells you that you can manufacture bumper on 3D printer, throw him out. We cannot. Because this is very integrated, this is a safety equipment. But if you are creating a version for a market where you want to integrate few lights and changes, 3D printing is the best technology because you don't have to invest in tooling. You quickly print it, you do ultrasonic welding on this, and your bumper is ready. Okay? And a lot of customers are doing it already. This is another excellent example. Car seat. How many of you have ventilated car seats? People who are using the phone are finding it boring. So you have to tell me how I can make it interesting for you. Okay? Ventilated car seat has a problem. If a person is heavy like me, the air doesn't circulate. Because the foam gets stuck together, the air is not able to flow through. What if I use a lattice structure like this instead of a foam? Then the air can easily pass. And I can have various resistance and I'll pass this out. Just press it from different sides. Depending on my design, I can vary the strength of the part. Okay. This is another example. This is example with Pooja Villai. She is an handicrafts, right? So on her car, if she wants Pooja written on the dashboard, Tata Motors will not create one part with Pooja written on it. But on 3D printers at the showroom, they can take an order and charge 3 times the cost of this part and supply Pooja written on it. Every car owner today has a figurine. Somebody has a Ganesha, somebody has our Sadhguru has made Shiva very popular, which is Adi Yogi photograph or a thing. And those can be printed. So there is a lot of amount of personalization. And just to give you an example, I bought this watch in Amazon sale. Okay, this watch say costed 15,000 rupees, for example. Okay, the rings on the top, just to customize, costed 5,000 rupees. The watch is 15,000. The rings are 5,000 rupees. Same is the case with the car. When you're personalizing it and you're making your car, you don't mind spending money. And if you tell your CFO that I'm going to get 15% more on this part in the car, he will say, okay, go ahead, make a few more. Okay? And then finally aftermarket. So these are some of the examples where 3D printers should be used. Okay? This is a car seat example. It's not something I was creating fiction. This is already in production. What you see here is all 3D printed. Okay? This is your spring, and on the spring, Ford actually created this part which is 3D printed. It makes sure that when the car is going in the wetland, the water is not stuck on the spring. And most of the Indian cars, if you go down the car, you will see rusting happening. If you have a jacket like this, the rusting will not happen. Another example, hybrid manufacturing. Outside is polypropylene. There is a film here, and you can ultrasonically weld the part. So whatever you do in injection molding, in terms of welding, in terms of spotting, you can do a 3D printing. And that's the advantage of using engineering material. This is another lovely example because my career started with these pipes, exhaust systems. Typically, when you do quality checks, you need receiver gauges, right? You do a receiver gauge and check whether go, no go, go, no go. When you have compound angles, it's a nightmare. In my time, it was a nightmare because we had very little knowledge of 3D printers, 3D CNC pipe bending. I interviewed few guys, they were worse than me. Because now we don't even teach them how to do a 3D bending of pipes. If you have to do this, you can create a receiving gauge in one shot on a 3D printer. Or you can print these individual blocks and create a fixture very, very quickly. And sir can tell you how much money they have to spend on getting a fixture ready. Again, a personalization example from BMW. Everybody wants fancy key fobs. Each one can be printed depending on the numbers, whether you like Dhoni or whether you like Tendulkar 10. You can print the numbers and you can have your customization. We quickly move. This is a good example. Ball bearing, the interior is now 3D printed. You have saved so much of metal out of the equation. Now these are 3 good examples. When you are doing special purpose machine, you don't, the MOQ is 1 or 2. You don't have to do tooling. You can straight away create the part using 3D printing. This, if you had done it on a conventional manner, you know what is this? This is basically a can turner. When the can, it goes and the can will come straight, a Coca-Cola can or anything. This is single printed, one piece. And you save so much of time. This is an example when you replace metal parts with polymer. Okay? And basically what you're doing is cost reduction, time reduction and sustainability. And it goes from processing, packaging machinery, agriculture, textile, woodworking machine, it is all across. We have only 3 women in the room, 3 or more, 3, right? But if you have bought L'Oreal any time, and most of you use your L'Oreal, 4 of you use L'Oreal? Okay. This holding fixture and the product samples are done on 3D printers. Colgate Palmolive, for example, which is right here in Gujarat, they use it for their tube holding devices. So imagine you have big size toothpaste and a small size toothpaste being manufactured on the same line. If you had metal clamp for holding, you have to unscrew it, put it across. But if you have snap fit 3D printed holders, it can be done very, very fast. So these are a lot of examples where 3D printer can be used. Do you have the drone part? That block? That right here, this one. Right on the left hand side. Here. This is the drone part, okay? And every drone in the country, today I'm very proud of 2 things. One is government initiative to make drone popular and focus, and that's what your point was. That you cannot say that, okay, we will be ahead of China. How? There has to be mass, right? How can you beat China? You can only beat China or anybody else by narrowing your focus. I want to be leader in drone industry. I want to be leader in automotive. I want to be leader in particular assembly of automotive. And that's how you do it. Drone industry has transformed. So many kids today have startup with 5 people, 10 people and use additive manufacturing. And I can't name the people who are using it, but there are a lot of parts from Idea Force today who use 3D printed drones, and their IPO is successful. 2 years back, nobody knew who Idea Force was. And these are very, very strong parts. You can throw it the way you want it, but it will not break. This is another example. End of arm tooling. You can create mesh structures like this and make it lightweight. This will basically reduce your requirement for servo motors strength. You can have lower wattage servo motors. You could have end of the arm tooling, which is hollow in nature. You can insert metal bits inside a 3D printed part so that you can use metal screws to fasten that whole product. And there are a lot of examples here mentioned. Finally, we come to the medical healthcare. And I will give you this example because this disrupted the industry. Coming to Sir's point that you need to disrupt. In US, the cost of getting your teeth straight around 4 years back was almost $250,000. Then there is a company who decided that can be disrupted, and they decided to do 3D printing. Any guesses how much they charge for now giving you the whole kit of getting your teeth straight? $1,500. The kit comes to your house, you take an impression, they scan it, they create molds, and they create 800 molds in one printing session, and then they thermoform it, cut it, trim it, and send it back to your home with a marking, first week, second week, third week. And you just basically insert, keep on inserting it, and your teeth are straight and you have close-up smile. If you're from my era, close-up smile was great. This is how, so all the molds are printed like this in one stack, 800 of them, and it's printed like this. The expertise we have, and now here I would like to introduce Franklin. So he will be talking about a lot of case studies. Franklin is from Premium. They are our global partners, manufacturing network partners. And the reason I said you don't have to buy the printer because Franklin is in the room. They have almost 13 different types of printers, and you can get right from metal insert to a polymer printer from them. I'm still talking. And these are basically post-processing, so you want to finish. Can you get me some finished parts, the painted items? No, that's colorful. This was the raw part, right?
Yes.
This is with chrome. We can also do retrofitting if you want. This is with white. This is with gray. So imagine if this was a vehicle part, you can personalize it depending on people's tastes. Similarly, when you are doing dentures, it has to be, if you do it very clear, you'll be able to see water droplets also, and it will look very odd that somebody is wearing a denture. So you need to have some smokiness. So it has to be just right. It's like a lens, right? If you have fog, not be able to. So you are able to manage this, and you are able to thermoform it using 3D printing. Last few slides. Now this is another example. How many of you have heard about Jaipur food? That's a classic example of Indian Jugaad. Okay? If that they were not there, a lot of people wouldn't have been able to walk. But the problem is that food is extremely uncomfortable. Because what you do is you take basically plaster of Paris and you start making a mold out of the amputated leg. And then you fit it, force fit it, and then you walk like this, and it basically cuts your amputated leg. But you can use 3D printing to create really nice prosthetics in How many of you have broken arms? Ever fractured arm? Remember that plaster? मम्मी का सुआ लेके जो स्वेटर बुनने वाला यहाँ से डाल के and we used to do खुजली, right? Because there was no aeration. Imagine if this was the plaster you had, completely aerated and very, very lightweight. Okay, again, another example of innovation. All the material which we use on a printer are engineering plastics. So PA11, PA12, polypropylene, PA12 glass bead, if you want something which requires strength, PA12 white. Then we have TPU. So if you want, I just circulated a TPU part around. And then you can have fits, you can have thread unions, you can have snap fit, you can do abrasive, you can do welding. Because this is engineering plastic, all this is possible. Okay? You can have raw, you can have paint, and you can have other finishes on this. Certification, very, very important. And there was a gentleman who used to do plastic testing, and you here. And we will work with you a lot because we need a lot of different kind of testing for different customers. But we supply a lot of test results already with the material we supply. Okay, these are sometimes the old 3D printer, when you expose the part on the UV light, this deforms. Imagine that Tata puts a side view mirror, which was done on a technology where the UV degradation is there. The side view mirror will come and will eventually fall. So you need to be careful what technology you're using, and hence you have UV resistance test to be done on the plastic before you use it on the vehicles. This is our portfolio. Okay? And I'm not going to talk about the price, I'm not going to talk which one you need to buy because you don't have to buy one right now. Okay? The next speaker, Franklin, from Premium, will talk about what they can do for you. My request to you is that I've taken more than required time, but idea was to have that bulb चढ़ना चाहिए सर के ऊपर. कि conventional बहुत हो गया. I have another toolkit. I'm not going to replace injection molding. I'm not going to replace milling. I'm not going to replace shaping machine or a lathe machine. But I have additional toolkit as a designer, people sitting there. And see, this is called herd. All the designers are sitting together by the way. All the professors are sitting right at the back. So this is herd. We try to sit with like-minded people. Okay? So when you get a component tomorrow and you're on your table, remember this webinar, or remember this seminar and say that, can I call Franklin or can I call Rajat and see if we can do it additive way and bring down your first sample timeline from 6 months to 3 days. And if you do that, very soon when the next step result, you will get a promotion as my company. Okay. Okay, last slide. I'm a virus on LinkedIn. Okay, so anybody who wants to connect LinkedIn we'll take the question answers. You can connect with me on LinkedIn. Response time is few seconds and few minutes. So you get a response. What you see at this area, this whole thing is HP's own digital factory. And sir mentioned about factories of the future. This is factory of the future. The entire setup is run by 2 engineers. We do work for Nike, we do work for Reebok, we do for all the shoe manufacturers, a lot of authorized processing. 2 engineers run the whole facility. We use AR/VR for machine maintenance, so they wear goggles and the engineers remotely guide them. Okay, remove this block, fix this block. It is all connected to SAP system. It's all connected to Siemens PLM systems. And it is open for any customer to visit. So if you're going to Barcelona, please let me know and we'd like to show you this. Not because we want to sell it to you, but we'd love to sell it to you, all of them. I'll be a rich guy, but the idea is to show you the future. And that's why HP is banking on this technology, because that's the power this technology holds. What Franklin will do in next half an hour? I put him on the spot. So in half an hour is to show you Indian examples. And if you are getting a little tired, please feel free to walk around, but I think this is important. Very rarely you get a sales guy who is compensated for selling the machine, telling you not to buy the machine. Okay? So Franklin, come on. I'm sure you will have a lot of questions on tolerances and things like that. We'll take the question answers at the end. In the interest of time, people like me cannot remain hungry for long. So we will like to finish quickly and then over the dinner we'll have all the question answers.
Thank you, Rajat, for the in-depth knowledge on additive manufacturing with few examples of weight reduction, etc. I will not go into the detail because we have a panel discussion and question answers as well. Now I request Mr. Dipen Bhai to come forward to present a memento to Rajat ji. Now I request Gopal Bhai to present a memento to Ms. Pooja Dave. Our next speaker, Mr. Franklin, is already on the dais. Let me introduce him. He is BTech in Automobile and MBA in International Business. He is management professional for more than 15 years of experience and specialized in business development, key account management, strategic partnership and global business acquisition. He is also honorary secretary for the Aerospace Industry Development Association of Tamil Nadu. He is also business head at Premium Solutions Private Limited, which is engaged in additive parts design for manufacturing company in Chennai. It has been having extensive range of 3D printing materials in metal and thermoplastics under one roof, and they offer products and services to aerospace, automotive, consumer electronics, and many more. Over to you.
Thank you. So very good evening everyone, and it is a very difficult task if you are a first speaker or a last speaker. So I am the last speaker. Most of the points already Mr. Rajat has covered, and he made our life easy, and our chief guest has covered how we have to be agile in the market, how we want to be a customer centric. So my time already I got a note from the organizers saying that how you can reduce the time. So that is a customer requirement now. So I need to meet the customer requirement. Thank you so much. And few of our friends thought about that it's a movie song break. So if you have went out, by then I'll introduce some concepts of 3D printing and then we'll go for examples. So one of the things I'm going to talk about is the solving the supply chain issue with the new additive manufacturing technology. So how many of you know additive manufacturing technology? Just raise your hand. Great, around 12 people. Great. How many of you know 3D printing? Many. So the technical term for 3D printing is called as additive manufacturing. So both are same. So most of you know what it is, additive manufacturing, and it is a 3D printing. So adding layer by layer is called as additive manufacturing, what Mr. Rajat has covered. And common man's language, if you add multiples of paper and getting a three-dimensional product, that's why it is a 3D printing. See the video of an HP, how the printers are getting printed. Layer by layer powder is getting, this is a liquid form. Powder is getting generated and the ink is getting spread and the heat lamp again spread and build the part. So design for additive manufacturing, Rajat ji has rightly covered that when you talk about designing, you talk about the constraints, but here it rewrites the rule book of your conventional methodology of design. So that's how the 3D printing start evaluating. So I'll quickly rush upon why we need additive manufacturing is design freedom, complexity, cost reduction, lightweight, mass. I think lightweight, next time onwards, I will not sit at the front row because I saw Rajat was just throwing out the components. So we will be little aware about that. I will just one away step out. So mass customization, what he was talking about, and the rapid prototyping, consolidation of components, and the sustainability. That's the why we need a 3D printing. Earlier days, people used to have 3D printers for concept understanding. That is what I have designed, whether I am making a component into that particular area. It was not a functional one, just to get the budget from the top management to move forward. That's how the concept of 3D printing arises. Concept of rapid prototype was coming in. Then people started thinking, oh, why not we do the design validation of the concept what I have done. That means subject to the functional test or subject to the fitment. That's the second horizon started in the additive manufacturing. What next happened? Then people started thinking, why not we go for a customization? Customization means one number I required in my name, multiple things produced in the same design with individualized name. Today I print something, a gear knob on my car. If a Tata Motors gives a gear knob with a name printed on your name, but it printed in one box, there is no multiple tool required. So people move on to the customization requirement of the need. Then jigs and fixtures. People started thinking on how we can make a simplified jigs and fixture without taking a block of a component, make a machined one and make a small jigs and fixture, wasting the entire material. That is being 3D printed. Spare parts availability. Today I make a car which is active for 3 years. After that, OEM will support for another 3 years or 5 years. So 8 years to 10 years support. After that, people sometimes love the Fiat car. If you want a spare parts, we don't have a tool. We don't have a part. 3D printing helps you just scan it, have a component, use it for it. and this is a digital digital inventory management. So no need to keep your inventory for your components. So that's how the evaluation started from conventional of your concept proving, design validation, then customization, jigs and fixtures and spare parts. So this is how we went. See how the additive manufacturing, that is the 3D printing, has moved on from prototyping, tooling, and it moved out to the end-use parts now today. Benefits: rapid prototyping and design iteration. You can go for multiple design iteration without investing on your hard tool. You want to make this kind of component for injection molding thing, you need to spend at least 1.5 lakh rupee. Today, you want to make a design iteration, this is just cost you 300 rupees. And you can make 5, 6, 7. How many iterations you want to do, you can do it within a week's time. Whereas in the injection molding, you have to wait for minimum 45 days time. Or a vacuum casting, you need to wait for minimum 15 days time. With the HP technology, you can move forward just 3 days time, you can able to get your concepts to your product. Low turnaround time, mass customization, this all talked about, so I am skipping this. Key challenges by the supply chain management. Sir is here, supply chain. He will talk many things. First is the warehouse management, that is the spare parts spot, minimum order quantity I need to maintain, I need to keep a warehouse, I need to have it. Second, cost of shipping a component from which part of the India, from Chennai to Gujarat to wherever it is, so freight is the biggest concern. Quality standard, whether I am using the industrial grade 3D printing material or not. Then product cost, then finally tooling cost. So these are the key challenges any company runs on the supply chain management. How it is going to address, if I select a part, whether it is going to be an injection molded component or a CNC molded component or I am going for a 3D printed component. Any buyer will have this concern when we start his product. So first one, how it reduces the lead time. As Mr. Rajat was talking about, is on the everything you can print it on one bill. See here, different design printed in one platform. If I want to do an injection molding, one injection tool like this, one like this, one like this, one like this. Even CNC you want to go forward, different programming I need to do with the CAD. But today you have a multiple component and one bill. If you want to have a system, I have a subsystems can be printed and then assembled here. Elimination of your tool time, faster prototype, complex geometry, a lattice structure. When Rajati was just throwing out, a lot of lightweight components are there with a lattice structure. And you have a consolidation of component. Earlier you want to print, earlier you want to make a component, this particular area is separate, this particular is separate, and this particular is separate. Now you have everything as printed as a one component, where you can able to eliminate your assembly line in your shop floor. Don't look, 3D printing will reduce your cost. There will not be any direct proportionate to your product, but you will have indirect benefits like line removal, removal of your supplier, risk assessments, all this being giving you a consolidated value. So see the 3D printing as a consolidated value of your component. Now how you reduce costs? You are eliminating tool, you are reducing the material wastage, there is no material wastage is happening, minimum material wastage, and on demand you can be able to make a product, so there is no inventory you are going to make, complex part with much simplicity. Are we using the 3D printed materials as per the industry standard? Yes. You have the conventional method powders or conventional method metals are available in the 3D printing standards by the global companies like BASF, Lubrizol. There are many companies can give you the same property of what you do in casted method, what you do in CNC method, what you do in the injection molding method. So this part is on the HP side. There are commodities available in, since it's a plastic environment, I want to cover the plastic one. So we have an amorphous, semi-crystalline and the thermoplastics. HP plays a major on the engineering aspect of nylon 11, nylon 12 on this particular area, and also on the commodity-based polypropylene. Most of the automotive applications are polypropylene or nylon 11. So today 3D printing materials are available. We can help you out to give you a solution. HP is available. Now Pooja is available to connect with you for the Gujarat market to take it forward. Now I'll get into the case study. Space industry. We have a proud moment with ISRO, but we happily say that we have also done something on the space industry. So this is a satellite holder. Customer came with a metal component in aluminum one. They said they want a lightweight material and it has to withstand the gravity and also it has to fly in the space. We converted the customer from metal to the polymer, that is nylon 12, and it also fly. See, it is tested, how it is being tested. It withstood 10G force, 10 times of your earth gravity, and also tested with the thermal isolation between minus 22 degree to 60 degree. And it is flying now, passed in the testing, and it is flying now in the space. This we have printed. So products are available, no tooling, no metal, just a design, printed, given to the customer, flying now. There is no lead time, there is no tool, there is no digital inventory, just a concept to fly. That's the first case study. Now second, this is a functional prototype of an off-highway, your construction equipment, the front dashboards. That's a big dashboard. Customer want to launch a vehicle with an aesthetical change. To make this dashboard a tooling, you all from the injection molding industry background, make this tooling will cost minimum 25 lakh rupee. And the minimum lead time will be 12 weeks lead time. Guess in how many days we could have given this component using 3D printing? Just 4 days. We cut it into multiple pieces because you have a constraint in printing the dimensions. We cut it into the multiple piece, that is 13 section, and we did the post-processing like dovetail joints. Here the concern is you need to have a warpage control here. That's where the design for additive manufacturing plays. That's where premium is going to support you. You come up with your problem, we understand what you need to do, then we will do the design for additive. Finally, we are given this component. Just the 5th day, including transit, he got the component. Whereas he need to wait for 12 weeks. If you want to do any design iteration, he can simply do the design iteration, give it back to us. Next 5th day, he will have the component. And this is a functional one. Alpha, beta trial, field trial. There is nobody is going to stand on this area. Non-payload application. People use this. Think on that angle. Now let's go to this is for one of the dashboards of an agricultural equipment manufacturer, a tractor manufacturer. Now, electric vehicle, as sir was talking, every 2 years a new car is coming. But electric vehicle, every 3 months we are listening that somebody is launching a two-wheeler. No investment for up to 300 vehicle. This is a complete two-wheeler body. Except frame is been welded. Balance everything 3D printed. And this vehicle, I am not supposed to tell the name, they are launching it next week. So we printed, painted and given to them, thus they are going to launch. So people will focus more on the core sector of electric motor, battery. Other things, leave it to us. We will help you out. Now drone industry, everywhere people work on drone. This drone, when customer came to us, this is during the COVID time, they want to print because they don't have time. Ministry of Defence was asking the drone for the surveillance purpose on the Himalayan area. Initial design was 400 gram because this product was designed for the injection molding methodology. He took the minimum thickness of 3 mm to 4 mm on certain areas. We redesigned this entire area and made the final component to 200 grams. What is the advantage for you? One, how much the drone flies high, the endurance part of it from 30 minutes to 45 minutes with the same battery capacity, and also you can able to increase the payload. Today I have this much zooming, but I need to do a 2 kilometer. So that's the advantage of 3D printing. What we did, see initially he came with this design. We made a reduction in wall thickness. We added the rib. If you reduce the thickness, warpage will happen. So we added the rib. When you add the rib, in the injection molding, your tool cost will go up. In 3D printing, just you add the rib, print it, you improve the internal structure, avoid the warpage. Now, lightweight. When you make a molded components, this will be a plain sheet. Here we are given a perforation. Just reduce certain grams of powder. Post-processing, as Rajji was talking about all these colorful paints. Here, this is printed and matte finish, mild painted, high painted. Here customer again, we thought that he will go with this. But customer asked me, by adding this, what is the gram you are increasing? 2 gram, 4 gram, 7 gram? Because every reduction of gram is going to increase the payload. So that's how we do a design work. Now, can the 3D printed parts have the inserts, holes? Yes, possible. You can do a self-tapping, you can do the insert with the heat sink, also you can do a locking mechanism. So this is we are done. Assembly. So in a 2 months' time, we delivered 150 drones and fly. It was tested, EMC, IP66, low temperature, high temperature, everything passed. That's the HP material, HP printer. That's the technology by the HP leaders. We are using it for the Indian market. Now, this is a fixture for an aerospace industry application. They were using a metal fixture. We converted them into the nylon material, a workpiece holder. Simple. No need to go for a sheet metal component, press it, cut it, laser weld it, nothing. Multiple piece into one. It's functional, working. Initially when customer came, he's a US customer. They know US technology, but they were not aware about in India market, what is happening. We are done with this. And now repeat orders, is converting all his jigs and fixtures to us. Silently we are working. Now, tooling industry, this is, you can see the drilling gun, 3D printer, for the launch of a product. Their customer's competitor, my customer's competitor, going to launch a new drilling machine. This news got by my customer. He wanted to launch the product immediately. He came to us a design, he printed, painted and given to them. He launched before the competition launched it. See the finish, see the features as you get in the injection mold stage. I am not telling that injection molding is going to replace. I am telling you for the low batch requirement, low volume requirement, design iterations, you can use this. No investment, launch it. So this is a set of things we have done. Finally, I need to talk about healthcare. Thanks, doctor, for our invitation. You are here. So healthcare, what we do, many things happening in the healthcare side. See, this is a patient having a knee ankle orthosis. The leg is like this. So doctor want to bring back the leg to the normal condition. What they do, they make a casted component, like a full casted component. The weight of a product will be approximately 8 kg to 12 kg. But 3D printing, we designed with the perforations. See, lightweight and also air ventilation is there. The challenge is, this girl is a mentally challenged girl from a poor background. She used to go to a trust work with the hospital. They load with a heavy thing. She is not able to express her weight, what is in the leg. Now, we 3D scan, converted this, and also we are given a provision where the locking mechanism is like every 5 degrees, release it. She is more comfortable. That's the 3D printing gives to the patient. Customization in the hospitals, I don't know how many are there from hospitals. Laparoscopic surgery, you make a hole and do that. After once the surgery over, the laparoscopic machine, they'll keep it on the table. Sometimes it falls, sometimes it will be there. There is a lot of possibility of damaging of the laparoscopy. We gave a simple solution, a cover for a laparoscopy. Just add it to the surgery table in the computer. See here. A simple mechanism. For that, if he has to go for injection molding, vacuum casting, huge cost. Just, and we printed the hospital name. After seeing the post in LinkedIn, a second hospital came, because the same laparoscopy they were using, we removed this logo, put the hospital logo. Customization. I sold it. So if you have any device folding, any mechanism you want to print, please reach to Pooja. Pooja will reach to us. Now this is one more mechanism. Based on the first success, the same hospital came to us. We are not able to give the complete structure, but I want this mechanism to be done in the 3D printer. We have done it and we have given, this is a 360 degree with a 10 degree incremental value. Now this is a splint. How many of you from the sheet metal industry here? Anybody from sheet metal industry? No. Okay. Sheet metal industry, in the shop floor, people will lift the sheet and put it on the press and take it out. When they take it out, the sharp edge will tear the skin. This is a problem of all the shop floor people. This is a problem of us because we are basically from the sheet metal fabrication background. We had the issue, then we gave us just scan a hand and we made this thing. Now there is no skin tearing or blood loss, nothing. People started using. Think 3D printing in your everyday shop floor. What I can do in that. Finally, few more slides I have. I just want on this area. With the MGF technology, you can go with the speed, precise, cost effective, more effectively is sustainable. It's a recyclable material. No other competitors are having the sustainable material. Quality is assured. Whatever example you saw in the MGF, all are functional, all are flying, all are used in the industry, all are used in the space application. Now, very few case studies on the metal because I need to do justice for my company. We are into the service industry of both metal and the plastics. This is one of the case study for the exhaust recirculatory valve. One of the off-highway vehicle customer came to us. They want to develop an engine. They want to improve the efficiency of an engine. He came with this design. This is casted machine. This is the thought process of the customer. We converted the customer from here to here. This is called as design for additive manufacturing. 1, weight reduction. 2, lead time. I'll tell you what we have done. EGR, everybody knows why EGR is used in the engine. I'm not boring you. When customer came, this is a cooling channel internal. But you cannot print it because the support will get generated. We removed this area, did some design for calculation, iteration 1, iteration 2, iteration 3. The iteration 1 was 44 hours sprint, iteration 2 was 32 hours sprint, and again iteration 3 is 32 hours. But see the weight reduction of around 14%. If you reduce the weight of a component, straight away you are reducing the cost of a component. Your carbon foot is getting reduced. If your end customer asks what is your carbon foot reduction, indirectly you are reducing your weight and you are going forward on this. Good that we have printed one component. When we did the study, it was 32 hours, but 2 components at 48 hours, this is how the component is. This is how the support structure is. This is printed in stainless steel 316L. Final component, machine and given to the customer. This, in 21 days, we did 5 iterations. 3 iterations are major iteration. This is possible only with 3D printing. You now understand why our chief guest said that every year new car is coming? This is what, sir?
We do it.
Thank you, sir. Please purchase our sir.
He's a hard negotiator. Marketing.
So second case study. Second case study with respect to the engine. This is on the engine cooling channel. Customer came with this is a cooling channel he want to do. We converted the cooling channel from the design iteration 1 to 3. See here how the design has changed. We are given a teardrop cross section so that there will not be no support. This is the final printed. We print test coupons. You can test the physical property and it meets your conventional methodology. So the conformal cooling plays a major role. Here I want to touch upon the injection molding components. You have a straight kind of cooling channels. We will make you a conventional or a conformal cooling, a small insert change. What will happen? The cooling will go along with the product. Say it is a curvature, the cooling will go along with the product. So think 3D printing not only into your production or a part. Think the parts making part is more important in the tooling industry. So these are examples. I'm skipping brake being used by the Bugattis and the high-end cars. Last, in the metal area, we work on healthcare, aerospace and the general industry. Always we are very happy that we work on the healthcare, saving a patient. Doctor, one of the case what we did. So this is a patient, see, this is one of the mandibular case. Mandibular means your jaw. The terminology in healthcare is mandibular. He came with this is a case. Convert your CT file. CT file as a patient I cannot read. I only know what it is. So we help doctors and the patient to read the CT file to convert the model. Where exactly the problem is. Today patient come to us, sir, what defect I have, can you please let us know. Today doctors are communicating to the patients what defect it is. So that's the first solution we do. Second, see this is the titanium implant. We designed it. Along with this is we call it as condyle. This is simple, a ball joint lock. A mechanism, but we can easily understand the finite element analysis of an engineering application because it's constant engineering level for an application. But here, I eat meat, so my bite is different. You eat only a vegetarian, your bite is different. Somebody eat only soft food, their bite is different. So, individual anatomy has a different bite correction. So, accordingly, we need to design. So, this is called as patient-specific implants. We have done this case. Along with that, we are given the cutting guide. This is possible only in 3D printing, individual cutting guide. Usually, the operation theatre, a surgeon who is working on this particular neck will open it. Sorry, a little bit awkward. Another doctor who is a plastic surgeon, open your leg. Open the bone of 100 mm. So this is open, this is open. The risk of a patient is always high. And doctor plastic surgeon, take the 100 mm, start making a cut. He'll fit, see, cut. That day, if he had a good food at home, he'll be good enough to cut it. If it's not, just put it. So, but here in 3D printing, just a comfortable life. We give a cutting guide, exactly measure it in the 3D system, give it to them. So 8 hours surgery is been converted into 6 hours or 4 hours, risk is reduced. And doctors will be little relaxed. We know the doctor's pain now. We understand how much pain they go through. After this cutting guide, people are happy. So this is a final implant. We give us a titanium implant with the ball joint, the surgical gate. See this model. This is 3D printed in HP. So everywhere we go, HP will be there. Fine, finally we make, these are the implants, and these are actual implants. Automotive prototype production, definitely possible. See, what are components possible here? Vague guess. These all are possible. Come to us. And then you buy a printer. So, already Rajatji covered this, I don't want to bore this subject. Finally making a justice to my company. I am from the company called Premium Solutions. We call it as your doorstep to the world of additive manufacturing. I'll tell why. Quickly jumping, I'm basically from a sheet metal background for last 40 years. We make drone components, we make car, doors, frames, front axles, and we got into medical in 2015. This is the consumables, your gloves, dental glove, everything we make. I mean, we import and give. And we are a company into design for additive manufacturing. We are the only company in South India having both metal and plastic industrial grade 3D printers. We work on 3 business vertical. Wherever we go, first we get the quality management system certified, whether aerospace or the healthcare, we got it. Now we are scouting for customer. Now I got one customer here. Now these are the certificates, what we have. And then I said your doorstep to the world of additive manufacturing. If you come to our facility, your doorstep is here. 2 metal, 4 thermoplastics. I can happily and proudly say that who is going to give me the second machine we were scouting? And Rajatji succeeded. He has given me the second machine just 1.5 months before. So we have 2 HP machines. One is for polypropylene material, another one is for nylon 12. Also we have a capability to make a polyurethane material in the HP technology. And all others are, you want the stainless steel, tool steel, Inconel titanium, you can able to print. Come to us. So these are, I'm just skipping, these are the capabilities of machine, material, composites. And this is a 1-minute video about our facility. So we are in an IT industry park. See, Industry 4.0, machines are in an IT park. At the ground floor. I'll make 1 more minute, sorry. So this, now we have a design office. This is a 2-year-old video. Now we have a center at the design office. So this is the first machine in metal, first in India with the 2 lasers 700 watts where we can run stainless steel tools. And third machine, hopefully soon, sir. So here we run polymer materials and also TPU polyurethane. So other plastic machine, FDM, resin based, and also we have now Mark Forge. That's a different technology for composites. This is for the healthcare titanium. We are the first one to have the electron beam melting technology. Fine. So finally, we as a company give you a solution in the generative design, additive manufacturing solution. And materials, multi-material under one roof, multi-technology under one roof, your doorstep to the world of additive manufacturing. All our parts are functional parts, no more prototype. And we work only on the batch requirement, low volume requirement. Thank you so much for listening to us. Thank you everyone. Thank you so much.
Charanji. You have touched the subject very nicely by the case studies. I request Dr. D.P. Solanki to come forward to present a memento to Mr. Franklin Daddy.
બીજું કાર્ડ ખાલી
I know you might have a lot of questions in your mind regarding 3D printing. So we have a separate session that is a panel discussion. So many questions would be answered after listening to particular discussions what is going on between the panelists and how it is being controlled by the moderator. And still if there are some questions in your mind, we have a question and answer session at the end. So now I request Mr. Shirish Devgi to come upon the stage to start the panel discussion and as a moderator. Leading experts in the plastics industry, machine manufacturing industry particularly, over the last 35 years, he has acted as of quality assurance, manufacturing systems, technology transfers, and executive functions of sales, marketing, HRD, and organizational development. He provided vital impedance to organization Kaizen and Lean initiatives. He is also associated with IPI as a life member. He was also past chairman IPI Ahmedabad chapter and working as a director at Plastic Machinery Manufacturers of India. I request Mr. Chetan Shah to come forward for the green welcome of Mr. Shirish Devgi. It's time to call upon our panelists. Our first panelist is IPI nominated industrial panelist, and I request Mr. Gaurang Shah, is a vice chairman National Seminar Committee IPI and past chairman IPI Vadodara chapter. Request Gaurang Bhai to please come on the stage. Mr. Gaurang Shah is an electrical engineer. Over the past 32 years, he has been instrumental in introduction and successful implementation of numerous innovative solutions for the Indian plastic processing and tooling industry. He is also associated with IPA and Tool and Gauge Manufacturers Association of India. He authored several publications and mostly they are centered towards the increasing product quality and productivity in plastics industry. Currently, he is director at Madhu Machines and Systems Private Limited. Factories at Bangalore and office at Vadodara, and manufacturing under overseas collaborations, state-of-the-art machines, processing equipment, tooling, technologies for plastic industry. I request Mr. Alpesh Gajjar, IPI Ahmedabad, to welcome Mr. Gaurang Shah. Now the first panelist was from industry. Now we have a second panelist from the academic. So I request Ms. Bhartiben Basantani, Plastic Technologist, to come forward on the stage. Ms. Bharti Basantani is an associate professor and head of Plastics Technology Department, LD College of Engineering, Ahmedabad. She has a vast academic experience of approximately 30 years in plastic processing, mold design, hydraulics, plastic materials, testing, composites, etc. She is also an active member of IPI, UDCT RME, AMA, IST, and she is currently enrolled as PhD scholar at Government Gujarat Technological University working on compostable plastics. To welcome her, I request Mr. Harindu Vyas, GC representative and honorary secretary IPA Vadodara chapter. Now I would like to invite all the distinguished speakers to come on the stage to part in the panel discussion. And with this, I hand over the forum to Mr. Shirish Divgi.
Good evening, everyone. Excuse me for my voice. I'm not well a couple of days, but I mean this subject was so interesting. I was very determined that I should come here for learning rather than moderating. Moderating was a small part of it. First of all, the presence here of such a large crowd and registration got closed early itself speaks volume for the interest in the subject. And I congratulate that organizing it in the right moment. And when I say right moment, it is, I led Milacron for almost 27 years, and before that I was in Windsor. So all my career went into injection molding. And when this additive manufacturing came, we were thinking that ये हमारा business खराब करेगा. And it went on, and since we had in Milacron, we had American collaboration. So there were a lot of discussions, and let me tell you that discussions happened exactly what you said. This is a complementing technology. So we should really promote it. One is to make parts. Second is to probably become HP's competitor in the future. That you are running a very successful business in handicrafts, right? And you also export. Of course, export is very challenging in terms of lead time and the qualities also has to be precise. So I'm sure you get a lot of leverage from this in terms of lead time as well as the quality and consistency. Looking at the future in handicrafts and maybe the toy industry is now coming up very fast. What do you think of the future of this industry related to 3D manufacturing? How it can grow multi-folds?
Thank you so much. So whenever the traditional Indian handicraft has been combined with modern aesthetics and new design ideas, it has been appreciated globally. And I really believe that with the technology that's handled to be very unique and be very nice. So in that perspective, when we work with interiors and architects, we want everything customized. We want customized nameplate. We want everything to be unique. At that very point, the technology of 3D printing is going to be very beneficial in the home decor segment as well. So I don't really think that any segment would be unrelated to 3D printing now. I hope I answered.
Absolutely, very well. But seeing you as a young entrepreneur and taking this blue ocean kind of business, it really encourages many, and I'm sure many will now start from tomorrow. They will start contacting three of you.
Thank you. I hope so. We look forward to speaking with everyone.
Actually, I had multiple questions, but we are running out of time. So my second question goes to Franklin. You are doing a wonderful job, but that's in Tamil Nadu. Now, how do you plan to, because in Gujarat, we don't get a stone unturned when there is a huge business opportunity, and you know that. So how do you plan to, expand your kind of, giving solutions in Gujarat?
Thank you so much for this opportunity, first of all. And we as a company are a 3-year-old company. I mean, we started with the Tamil Nadu, but now we are doing business with the entire India, and we are exporting also. And for the Gujarat market, yes, we don't see Gujarat businessmen as our competitors. We want to make them as complementing each other. That's our first step. We are now associating with Innova Solutions, that is with Pooja. So Pooja will represent the Gujarat market, and she will try to understand the market for the 3D printing industry, get the service from us and give it to the market. If necessary requirements are there, we are ready to invest in Gujarat in association with you as a partner.
Thank you. One question which I learned from your limitation, from presentation, is it a limitation of material? Because you said specifically some material, but plastic industry, comprises of many materials. So, is there a limitation of the raw material which is used? And the second part of this question is, you also mentioned about recyclability. I was always wondering, this can also handle recycling and how it is, the recycled product getting converted into material, because that's the topic of the next 20 years.
Really a good question. See, 3D printing is there for the last 25 years. Lot of research works are going on with respect to the meteorology. Now people have come out with the materials on commodity-based materials for the productionization. Today, polypropylene is highly used and it is available for production. And then single crystalline material is available, it is in production. So HP's job is to create, identify application, develop the material component with the support of BASF or Lubrizol, come to the market. Like that, majority of the product, I will not say we have the entire spectrum of material available in 3D printing. Around 50% of the material only available in 3D printing, which are required in volumes are available. There are many materials are still in the research stage. Say example, today you need a aerospace high temperature material, single crystal material, crack prone material, that is CM247. Still it is casted one. People are trying hardly how to make it into a 3D printed component. Lot of industries, IIT in collaboration with academia, Fraunhofer in collaboration with the German companies, developments are going on. Soon we will have the material, at least 75% of the commodity material will be available by 2035. So there are restrictions available.
Good. My next question goes to Rajat ji. It was a very nice presentation. You made it very exciting also. The whole issue comes in thinking of a 3D printer. Whether you buy it or whether you outsource it is based on the cost. And you touched upon it, both of you. There is a hesitation because when we were working in Electron, we always explored specifically for aftermarket parts. Because the couplings which are outdated, but you cannot change the entire height, motor and pump. And this coupling was outdated. So we explored these 3D printing, but the effort stopped because of cost. Any comment on this? Maybe there is a change now.
Yeah, so as I said, I'm a very strange salesman. I was not trying to sell the products I'm gold for. The reason is that we believe that if you cannot get a ROI in 1 year's time of the investment, you should not invest. So when you call us that we want to buy a printer, we do a calculation and tell you that your ROI is taking 2 years, please get more volume before you buy the printer. But your work can start today. We have set up centers in every cluster. Noida, Chennai, Bombay, Pune, where we have people like Franklin who have invested, who are expert in the technology to give you service today. And also, you need not buy the printer, you can always lease the printer. We lease the printer. And the technology keeps changing, right? So end of the lease period, you can say that HP, please take back the printer and give me a new printer in the lease contract. And that is also possible. And we don't only lease the printer, but also the software, third party, including computers. Everything will be leased to you. So you don't have to do a OPEX investment, CAPEX investment, you do a OPEX investment. And when we do a business plan with you, we factor that monthly this is the installment you're going to pay, this is your inflow. So we will not let you buy the printer till the time we are convinced that you will get the ROI. And that is a mantra which we have been working, and from 2019 onwards till today, we have been able to capture the market and we are number one player for production plants. So that, I hope that answers the question.
Absolutely, absolutely. My next question goes to Gaurang Bhai. In fact, when you were making presentations, I was thinking, there are a lot of benefits which we heard, but what are the challenges? And, that industry is definitely, other than the cost and all these things, there may be some challenges in terms of processing and all. So, I think it is the best way to check with the industry expert and a very learned person, because I know Gaurangbari gets into depth of any future technical subject. So what are the challenges you think should be posed to the 3D experts?
So, thank you, Divyaji. Firstly, I would like to thank the IPI Ahmedabad chapter team to invite me for this very interesting event, which could probably be also called Future is Here. Coming from a background of subtractive manufacturing and formative manufacturing, when I say subtractive manufacturing, I'm saying from the injection mold manufacturing industry and also the what you refer as the die casting. So basically tooling manufacturing industry. I think I would say a lot has been said on the additive manufacturing for plastics. So probably I can deal a little bit on metal additive manufacturing or selective laser melting. Not too far back in time, I very vividly recollect that whenever we had a project which would kind of accommodate this kind of technology, we had to import the jobs from Europe. Things have changed a lot since then. You have experts here now in India with the printing equipment, machinery, and even the design facilities. Having said that, my views would reflect the challenges which are coming from this industry, which is again the tool making. Very broadly, I feel that this can be categorized under two headings. One is the first one being technical. So the design aspect is extremely important. Okay, please allow me, sir, to cite a case where we were working on a plastic injection mold, which was for an aerosol spray cap. Now, as you all know, aerosols, the spray caps have a very minute hole, and this particular cap was having a very interesting geometry. So the conventional methodology of cooling was, of course, challenging for the part. So we made the tool, we manufactured the tool, and we could achieve a cycle time of around 22.5 seconds, and a very large part of it was around the cooling. The machine had to literally wait till the part was cooled and it could be ejected, would open and ejected, right? Subsequently, when the repeat mold was to be made, we said that there was a conscious need and decision with the end customer to improve this cooling time. So we went ahead with metal 3D printing, and the core, basically the core for the mold was made with metal 3D printing. The channels, what he mentioned was, conformal cooling, so that could follow the part geometry, and we could achieve a cycle time of 14 to 14.5 seconds, right? And that's a huge reduction of 30-35%. Now let us understand that probably that won't be the case in every application. What I wanted to highlight here is the design inputs that go into conceptualizing such a part, right? This is very critical because the technology is not percolated down to the end user. So one key challenge area is the design. Secondly is the knowledge of materials. Okay, so for example, we use Marizin steel, which is a high cobalt, high nickel steel, and the advantage of that is when you use that sintered powder, the part is formed, the core is formed, and of course you have to do very minimal subtractive work on it finally. But the big advantage is you don't need to heat it up to very high temperatures, probably around 500 degrees, and then it is progressively cooled down, and we could achieve an amazing hardness of 56 HRC, right? Which would otherwise, the cores when they are manufactured with conventional good steels, I would say, would give us 50 to 52 HRC. Now this is extremely important when the cores are especially having ejector pins, they are having sliding surfaces, etc. Right? And which help in the longevity of course. So the second big challenge I would say is on the materials. So how this can be addressed? One is on the design, second is on materials. There are quite a few challenges, but I think these two would probably be what I can propose.
Absolutely. Any comments on that?
Today if I go out, probably they will be interested in manufacturing material. And that brings me to the topic that we are very keen to work with material manufacturers in India and see if we can have innovation made in India material. For example, PA11, the caster beams are all grown in India, and we produce that PA11 out of India using it.
And do you think this will go forward?
There's no reason why it will not go, because, for example, fire retardancy. Today, that is one challenge we are trying to solve. That how can we have native 3D printed parts fire retardant? The challenge there is that I have to use 100% new powder. We are trying to see that normally we use 80-20. 20% is new powder, 80% is recycled powder. We want to reach that level in FR. The moment we do it, the entire mobility industry will require it. So we are spending, and that's why the $1 billion is going, doing new research in material so that we can bridge that 25% remaining gap and get new materials in.
Rajatji, do you think bioplastic is also an area of research which you are doing?
Oh, I would say the possibilities are endless. People are printing chocolates, people are printing stem cells, people are printing grafts, screen grafts.
Yeah, we recently saw a video where Netanyahu is eating chicken out of 3D printing.
Yeah, so Singapore, you have most of you are vegetarians, so I should not be talking, but yes, a meat can be 3D printed. The other thing that I want to highlight here is that our focus is only on making 3D printing additive manufacturing, which means volume. And I'm very happy to say that without launching the metal printer, we have the first 2 printers coming in India before we even be launched. So that shows that the Indian industry is catching up. And for all the young people like Pooja, they have the power to employ 450 women for her work. And we don't have to sell for us to be employed. We can do 3D printings, set up small shops, be a drone company with just 10 people and be exporter of drone. And I have it in my pocket, the case study which we will be launching tomorrow. Just 10 people, 2 IIT students with 8 interns are manufacturing drone, and that too autonomous out of IIT campus in Delhi with zero funding support. They have done it from their own pocket. And that's the power of using new technology properly. And if all the professors here, we are more than happy to participate and see how we can contribute to your students, because as Sir was mentioning, there's a big void of talent. Industry needs something else and we are teaching something else in the education. So to bridge the gap, it's people like HP who have to step forward and impart that knowledge. We call it train the teacher, to impart the latest technology. And I think China is the wrong example. We can beat Germany if we do it right.
Rajat, you actually stole my next question. I was about to ask Bharti ji that, what are the possibilities of, how students can be the next generation of these new technologies, and your party answered it. But on that topic, how can we upgrade the students? And I know very well that you always pushed me to come and give, send experts from Electron and my colleague here, Apurva, and they were regular. You have that hunger for educating your students as the new technologies come. So rather than that, do you think any other help or efforts are needed for the educational institute from industries or from OEMs like this in 3D?
So, thank you IPI for inviting me here. Today's session was a real eye-opener for me. Immense possibilities, and what I can foresee is the immense talents coming up from the students in terms of startups also. Our students are always hungry for learning, and the first thing, as you rightly said, the expert talks by learned people like him. Second is, one thing that I can foresee is, like in our college we have a lot of centers of excellence. So if you think it's right, you could partner with the government and set up a center of excellence wherein research projects for developing the materials, as you very rightly said, developing newer applications could come up, and our students are very intelligent. They know how to extract from even little bit you tell them, they'll be able to do it.
Talking about incubation centers.
Yes, incubation centers is one thing that I definitely foresee here, and I personally could, whatever I heard today, this is my first seminar where I've heard about so much about 3D printing. I knew it as a technology, and there is a 3D printer in our center, one of the Siemens Center of Excellence. But we are not much exposed to it. So I personally feel, and it's my open invitation to both of you to please come to our institute. We will organize for all the branches of engineering. Let the students listen to this. Let the professors listen to this. Then some new research ideas will prop up, and see, our institute has grown so far that we are focusing so much on patents and research and everything. So I personally feel that please come and educate us more and more, and let there be a partnership with the government in setting up such incubation centers. Thank you very much.
I just want to add about the Innovation and Incubation Center. We started our company for the commercial purpose, but later we realized that the skill was not available in the market, and we were struggling to get the additive manufacturing people to hire. So what we have done, we have started the Innovation and Incubation Center for Additive Manufacturing with the help of the leading software company, that is Materialize. We are the first one to have an Innovation and Incubation Center for Additive Manufacturing for the healthcare people. The doctors who want to start some medical device, they come to us, we train the doctors, and then we go for 3D printing and do that. That is one. Two, we started working with the institutes to bring the third year end student or the fourth year, the 7th semester student, come for the industry visit, have a one-day training session on completely what is designed for additive manufacturing, what are the design scope we can do. These are we are doing at a free of cost. Third, we work with the Tamil Nadu government. Center of Excellence, already Tamil Nadu government has invested in the metal, and we have been identified as the industry partner to run the center for the GE's aerospace engine. So that's how we are open for it. Even we are ready to work with you along with the HP to take up this kind of Center of Excellence. To be precise, based on this experience, from US Cincinnati, the university called us and they said, why not you start a Center of Excellence in Cincinnati? See, people started calling Indian people to talk about the advanced manufacturing. Thank you.
One thing I would like to add here is, in our semester 8, the final semester, we made industrial training compulsory for all the students, for all branches of engineering. So if you have an opening where some students could be sent to your premises, train them and make them do some projects, that would also be another thing that in which you could have fresh talent coming to you onwardly.
Madam, principally I feel, IPI does a lot of training in the halls like this. Then, as you said, we do industrial training, but incubation centers are most effective ones because they not only solve the industry problems, but also expose students to get into the technology.
Yes.
I think Vibrant Gujarat is around the corner, so there is a MOU to be signed here.
Please do it right away. Let's do it on Monday.
So government is taking a lot of steps, and sometimes it gets unnoticed. In all this car census and all that, we miss out the silver lining which is happening in India. So government actually set up a commission called National Commission for Additive Manufacturing under the Ministry of Electronics and Telecommunication. They set up the center in Hyderabad at the Osmania University, and they're opening up new centers. Ministry of MSME has 2 teams which has got 3D printing. HP has almost 8 centers now running. So to your point, we will be more than happy to request Karthik's boss, Franklin's boss, and other bosses to have at least 5 to 6 students in every semester to come and have a hands-on training on the 3D printer. That's a commitment I've given to you. And finally, because we are running late for the dinner, and I'm hungry, so I would like to thank ITI. This was a fabulously organized event, and as a learning from this event, we are going to partner with you for All India and do this education. You have a question?
So tapping is a singular data process.
We will take questions and thank you all the panelists for the wonderful discussions. Actually, I can see the success of this seminar on a lighter note, because other than Rajatji, no one is hungry. Everyone is hungry to know more and more about 3D printing, but no one is hungry about the data.
We are hungry of information.
So that's what I'm saying. So on a lighter note, as Rajatji said, we are going out of time. We'll take only 2 or 3 questions, and for other questions, I request audience to get it clear during the networking dinner. And over to the audience, the first question. Yes, bye-bye.
Everybody who sent me the LinkedIn request, I've already accepted it.
Oh. Thank you, HP and Franklin, for such a wonderful sharing. As an ITI chairman, I would really appreciate your gesture taking this exercise across India. Yes, we do such activities. We have multiple centers across India where we can do this. So I promise we will take it up in the next governing council and we'll get back to you. My question is to you about metal part. Do you need to anneal it? Do you need to, when you build a metal part, do you need to anneal or stress relieving activities are required?
That's a very good question.
And if there is an abrasive environment for the part, do you do hardening or case hardening or nitriding or anything? Is it possible?
There are 2 technologies available in additive manufacturing. One is laser based, another one is electron beam based technology. Laser based, when you build every layer, the stress is being generated. So after the print, the part has to go for a stress relieving, and whatever the hardness you need, then you need to go for a solution hardening or whatever required on that. If you print a technology, a part in electron beam melting technology, each build is at the high temperature and layer is preheated. So the layer is getting, stress is getting relieved. So there is no need of heat treatment for those parts. Still, you want to have, if it is high fatigue part, then you need to go for a heating process. So 3D printed components will go for a heat treatment process depending upon your requirement.
With the standard heat treatment?
Standard, if you say your 17.4 pH, sorry, 17.4 pH or tool steel 1.27, same H900 treatment we need to go for.
But there is no MS used anywhere, EN series or MS?
Equivalent is available.
Equivalent
is available.
Yes, please.
My question to Mr. Rajas sir is isotactic is a polypropylene. Polypropylene is a crystalline material. In isotactic is a manufacturing by Ziegler Natta and fluidized bed technology. So is a polar structure and crystalline. I was saw your product is a driven technology gear mechanism. You can throw the product. The plastic material is itself a flexible mechanical thermal property. So PA12 is a 6 plus 6 carbon is a additional add in plastic. So my question that is there any biodegradable plastic compared to invented in a 3D is a 4D material, 5D material and 6D material is a ongoing work. Is a like latex rubber to invent. If I have any biodegradable plastic material to invent impossible to 3D material now is a working.
Have you done any biodegradable 3D? That's it.
Okay, let's make, in the interest of time, drop me a mail. I'll get you connected with the material scientist. Ask this question. This is a good question. Let them answer.
Because isotech is a polar material and electric properties are excellent. Is a Tesla is a invented. Is a tire is a polar structure. So is a non-replace to
When I was a student, I didn't read my textbooks properly, so I will not answer.
No problem. You can write down for yourself and you will also be by the email, as I said.
Let the scientist answer it properly so that you get satisfied. I am one person who never gives answers when I don't know the answer.
Thank you.
Thank you.
We have the last question now. If anyone, yes.
Can I?
Of course.
As you said, frankly, that you would like to take the students and do it. But my suggestion or my request will be, why not to take the industrial team also? Because already people who are running the industry, they may not be aware, and real innovation or real business is going to come from them. So if you can educate us from that angle, it will help.
Really,
this is my feeling.
No, really thank you. We are more interested to do that. Just for an example, one of the leading medical device company globally, we have trained the first 15 R&D engineers for 2 days at our facility. We have trained them on how to design the 3D printed component for the patient-specific implants. Now the second batch we are going to work it in the month of January. We are open to have for automotive industry also.
So only small suggestion here, instead of we coming in Tamil Nadu and enjoying the idli sambar, why don't you come to us and enjoy our fafra here? So all of us will be here and you can enjoy.
No, I promise not to sell anything, but we have professional services, and even without buying the printers, we do training programs, and these are both on-site and off-site. So you can, our experts from Barcelona will do a team session and can train your people without having a printer. So these are basically people who work with all the major automotive companies. And just to give you one example, with the person sitting next to me, they were facing some problem with a particular material in terms of warpage. We have flown in the engineer from US. On first, he's coming and training the entire team on how to handle that material. And that's the advantage of companies like HP or any company which has got, for example, GE, to get into 3D space, because we have other revenues to support this activity of bringing up the industry. Spending $1 billion in R&D on 3D printing was not an easy decision, because we are ruled by stock exchange, and our stockholders will always question why are you doing $1 billion when you could get much faster revenue return by designing 10 different laptops and selling them in mass market. But we call it being ready for the future. And we thought it would take 10 years, but that future has come in 2 years' time. So we have experts who will train you even without buying the printer. And they will teach you design for additive manufacturing, part selection, and these are rich consultants with 15, 20, 25 years of experience in the industry.
Just to add to your thing, Rajat, what we do with our industry, with our supplier partners, we organize such technology use and have a team calls, team meetings. And the subject matter expert, they give all these live examples from the industry, solutions and technology, maybe for a short time, 45 minutes to 1 hour. So my request will be to you, if we can have such a team call, so that suppliers and supply partners can sit at their end, they can have in their conference hall small, and the entire team can participate. Lot of things, lot of ideas, brainstorming can happen at that end. And really it will change the different tone in the industry. They will be made aware in the large scale in a very short time.
And anybody who wants to start a startup in medical domain, Monday 11:30 we are talking on medical application, complimentary for everybody to join and listen to team call 11 to 12:30. 11 to 12:30. And we have a company called Hyperganics. I was talking about the tree example, right? Generative design. They will talk about how generative design can help, and they are not present in India. We are getting them from abroad, dialing from Germany and doing the lecture, and we do it regularly. So one advantage of connecting with me on LinkedIn and Sridevi on LinkedIn is that you will get all the invites of all the seminars we do.
Okay, now to summing up the seminar, I request Mr. Chetan Shah, Honorary Secretary, IP Ahmedabad Chapter, to offer word of thanks.
Before you start, thank you for taking a trouble of me, allowing me to trouble you so much.
No, it's my duty, sir, and me and my team are extremely happy to conduct such a large crowded seminar, and a lot of brainstorming already had been happened. I am very sorry that I am the last person in between you and dinner, but I have to complete my rituals, without which it will be not the complete seminar. I would like to thank all the people, my committee members, my sponsors, FP, and the event management team. Everybody had played a beautiful role, and with the help of each and everyone's, this seminar had become very successful. So thank you all, and we invite all of you to join us at beautiful dinner. Thank you. Dinner is behind you in the low. IPL member, please come to us and join us. Ravindraji, please also.
નહીં બીજું કાર્ડ લીધું એક કાર્ડ કાઢી નાખો બેટો લોટ પ્રમાણે થઈ હતો ગ્રુપિંગ આવી
I'm sorry, I'm
Not slow.
I don't have to pay.
તમારી જગ્યાએ લેવા પડે ગભરાટ નહીં તમે
ઉભો રહેજો વેઇટ કરાવો